Good morning, afternoon or evening to our guests and audience, wherever you might be. This event was organised with the support of the good folks from Stand Up for Nuclear and the Australian Nuclear Association. It's our second online event. For those of you who've not seen our first event, I highly recommend it, and we'll post the link in the show notes below. My name is James Flay, and I live in Perth, Western Australia. I studied and practiced electrical engineering before moving into systems engineering as part of a multidisciplinary engineering teams. I've worked in various parts of the energy sector for 16 years, including gas power generation, LNG, upstream gas production, utility scale and household solar energy. And I worked in technical, managerial and commercial advisory roles. So through this very circuitous route, I came to the conclusion that nuclear energy has a unique combination of qualities, which makes it an essential component of Australia's energy future. And I founded Down Under Nuclear Energy in 2018 to advance this idea. I'd also like to introduce a good friend of mine and the co-host, Helen Cook. Helen is the founder and the principal of G&E Advisory, a law and advisory practice dedicated to all aspects of the civil nuclear industry. She's published the definitive text on global nuclear law, advised many governments on their nuclear projects and programs and transactions, and she is recognised by the International Atomic Energy Agency as a nuclear law expert. She's also on the executive committee of the Australian Nuclear Association. So welcome, Helen.
Thank you very much, James. It's great to be with you all today. Reducing emissions from energy generation is clearly at the forefront of the global agenda. For Australia, goals versus targets aside, emissions reduction means progressively moving away from fossil fuels. In particular, the shutdown of our coal-fired power stations, which have historically been and are still currently the backbone of our energy system. So an important question is what will become of our coal communities that have built up around these coal-fired power plants and operated them expertly for decades. We're going to hear today about the likely impacts on these communities, as well as exploring whether and how nuclear energy offers a solution to safeguard the prosperity of the communities as well as our nation. To that end, we've assembled a fantastic panel today with representatives from the Australian and US coal communities, as well as the US and Canadian nuclear communities. So with that, I will just say that I'm not wearing a very strange outfit here. I'm actually holding my daughter, who has decided to join us this morning and listen in. But I'll turn over to James now to introduce our panelists.
Wonderful, thank you, Helen. So we've got seven panelists, and I'll introduce them in no particular order. We've got Sheila Wittick. Sheila's been a nuclear operator for Bruce Power in Ontario, Canada for 9 years. She was born and raised on a beef farm and currently resides in Teeswater, Ontario, with her husband and 2 kids. She has 2 degrees in teaching and has also completed a power operator apprenticeship. She's part of the Canadian chapter of Mums for Nuclear and the founder of Willing to Listen, an advocacy group trying to counter disinformation about a planned deep geological repository for nuclear waste, which will be developed in her region. Thanks, Sheila. Heather Hoff. Heather has a material engineering degree and has worked at the Diablo Canyon Nuclear Power Station in California for 18 years, where she is a reactor operator. She cares deeply for both the natural environment and humanity and believes nuclear power is necessary to enable people to overcome poverty whilst also living in concert with our natural world. For this reason, she co-founded the advocacy group Mothers for Nuclear, where she works to share her knowledge and experience with people who are less comfortable with nuclear power, particularly mums and women. Randall Luthi is the Chief Energy Advisor to the Governor of Wyoming, and he previously served in the Wyoming House of Reps starting in 1995, and this included a 2-year stint as Speaker of the House. A rancher and an attorney, Randall has held senior positions at several national agencies which focus on natural resource management. Di Snedden and Shane Davey from the Upper Hunter region of New South Wales are an editor-publisher team, and they publish 2 community newspapers, including one which is called At the Coalface, and we're very lucky to have them today. Graham Middlemiss is the former mayor and current councillor of the Latrobe City Council in Victoria, Australia, which is an important coal power region in Australia's southern and eastern states. He is also a former coal power station operator. And finally, Joe Italiano. Joe has spent 44 years in publishing and is a former WA regional manager for Fairfax Media and Rural Press before retiring in 2013. He was elected to Collie Shire Council in 2015 and re-elected in 2019. Last year, he came out of retirement to launch the Collie River Valley Bulletin newspaper following the demise of the town's 114-year-old local paper. Collie in Western Australia is the sole source of coal power and the bedrock of our grid on the west coast of Australia. So we're very lucky to have all our participants. One of the things that we're looking for from our Australian participants is not that they were pro-nuclear, but that they had an open mind. So I think we're in pretty good company today. So if you don't mind, I'd like to ask the first question before handing it over to the participants. So I just want to start by providing a little background information about recently announced plans to replace coal power for a nuclear power in the United States of Wyoming, before asking a question of Randall. TerraPower is a US nuclear technology provider who has Bill Gates as a long-term backer, and they were recently awarded a very large grant to build a demonstration reactor. They've decided that this demonstration reactor will in fact be a full-sized reactor, which will eventually go into commercial service. They're partnering with Rocky Mountain Power to bring this project to fruition by 2027. Now, TerraPower reactor technology is very different from standard light water reactors, but I prefer to steer clear of the technical aspects today and focus on why this is happening in Wyoming and how the proposal has been received by the people of these Wyoming communities. For context, Wyoming is much like Australia. It is an energy superpower. Apart from exports of coal, oil, gas, and uranium, Wyoming also exports a great deal, in fact, the bulk of its electricity from its coal power stations across state borders. And it has a large wind sector as well. And presumably this is a decent revenue earner for the state. So Randall, why has TerraPower selected Wyoming as their preferred destination for the first project? And how do the people of Wyoming feel about it?
Well, that's certainly a loaded question, but I'm glad to try and answer it. And James, first of all, thank you all for this opportunity. It has been an interesting ride, and it's just the beginning of this ride for nuclear power in Wyoming. And I did want to just back up what you said. I think Wyoming and Australia are very, very similar in this aspect. I mean, Wyoming has provided, we have about 6 coal-fired plants. 80% of the electricity that we make goes somewhere else. And even now, approximately about 40% of the power in the United States, is still coming from coal and largely from Wyoming coal. So we've spent 2 generations really riding the benefit of coal and coal-fired electricity. But as you say, the market is changing, attitudes are changing, politics are changing, and we're somewhat the stick in the mud in that, and because coal is so important to Wyoming. So we're actually working to, and I'll just mention it probably just once or twice. I mean, our big effort, it also involves carbon capture. It's our goal that we can keep some of these coal-fired plants going. Wyoming, nearly 5,000 people are employed by the coal mining industry, and that's direct. So you can imagine what it is as you spread it out on other effects. I think one of the reasons that Wyoming was selected by Natrium is because of Rocky Mountain Power. They're the largest publicly traded utility by far in Wyoming. They're under tremendous pressure. A lot of their customers are in Washington, Oregon, Northern California. And a lot of those customers want fossil-free power. And yet they get so much of their power from Wyoming. So they're under quite a bit of pressure to make some kind of changes. And we've been putting the finger on them to try and do more with, keeping these coal-fired plants burning, increasing their efficiency, reducing their emissions. And so we've actually passed laws to promote things like carbon capture. So I think they saw it as an opportunity to actually try this demonstration project. There's 4 communities they're looking at. Wyoming has no money invested in it. Should it work, it will be purely a private endeavor with a lot of federal money. And it's a 7-year project. They've committed to have it finished by then. And it's very interesting what happened beforehand. They did some polling, and I know we want to talk about, you've got some polling as well. And their polling was actually quite positive. It was over 50%, sometimes just around the 61%, when asked, what do you think about using nuclear power to replace a coal-fired plant? And one of the attitudes that I think has changed is within the coal communities themselves. Because if you go strictly with wind and solar, which again, Wyoming has a good share of, but if you do that to replace a coal-fired plant, you've lost the coal mine and you've lost the coal-fired plant. If you go with this nuclear reactor, the small modular nuclear, you're probably still losing the coal mine, but they're telling us that the employment of the nuclear power plant will be the same, if not greater, of the coal-fired plant. So that helps, ease that fear about jobs. We've already started talks about training. We've started talks about how, we can get workers into Wyoming. So we're pleased that this is happening. Again, there's quite a bit of time frame. Things could go wrong, but right now things are looking pretty good, James. I think you're muted.
Thanks, Randall. I am muted. So thank you very much. And with that, I'll put it out to the Australian participants to direct questions to Sheila, Heather, and Randall.
Well, I'll start. I just sort of wondered, you talk about the jobs and the transfer of jobs to, is there a skill set that needs to be significantly different to what's happening in the coal-powered fire stations to what, you're proposing or you're doing?
And I'm sorry, you were breaking up, and you have just enough of an accent that I may not be familiar with, that I didn't catch all that. So if you wouldn't mind maybe just repeating it. Yes.
I apologise, and I will try and speak more in your accent. How's that?
Well,
anyway,
we have a boring accent, so I mean, really, that's why I'm embarrassed to be with this crew. I can't even fake a decent accent. Yeah.
My question was about the transfer of skills from coal power stations to nuclear. How challenging has that been?
We're just getting to know that. You've got to, as TerraPower has explained it to us, a coal-fired plant generates electricity. A uranium-fired plant generates electricity. Most of those jobs are the same thing. It involves monitoring. It involves, watching the fuel source, controlling the fuel source. And so as far as specific nuclear training, that will not be the majority of the employees. And they think that the cross-training is going to be relatively easy.
I wonder if one of our nuclear operators would like to jump in and say a few words there, Heather.
Yeah, I will. Yeah, I've never worked at a coal plant, but I do work at a nuclear plant. I've been there 18 years now, and we do hire a lot of engineers, which is really cool. That's originally why I was interested in working at Diablo Canyon, though I did not get a job as an engineer there. When I graduated, there were no engineering jobs anywhere to be found, so I applied to be an operator. And in my operator class, there was a milkman and a guy who had worked at the state hospital, and a wide range of people that some of them had high school degrees only, some of them had some college. And so there's really, a large variety of people that can go into the positions of operating plants. There's a lot of maintenance work, construction like carpentry and electrical work, and all of those that are more like trade style careers, and also more higher education required, like engineering type jobs. And that's one of the things that I really love about being at the nuclear plant, is there's so much variety of different options and different people as well. When you mentioned that there are 5,000 people in the coal mines, that made me just, compared to my power plant, Diablo Canyon, we have about 1,500 people working there. So if you built, 5 large nuclear plants in Wyoming, that would cover all of your coal mining. So I would say that's definitely a preferable job to being in the coal mine. So, but yeah, I really enjoy it, and I'm happy to answer any specific questions that people have about nuclear jobs.
You're doing what you're doing, Randall, and Heather, you work in a nuclear power environment. What is the general feeling of the communities surrounding where this is happening? And what sort of things have you, as your company undertaken to I guess educate, make people comfortable with the technology and the safety around it, because that's obviously the big thing. Probably here in Australia, I'd say everyone immediately thinks Fukushima and Chernobyl, and I have no doubt that the technology and the levels of safety are entirely different to those situations, and the future. So basically, how does the future of nuclear look in a positive way?
That's a huge question. I started a nonprofit called Mothers for Nuclear with the goal of communicating about nuclear differently. So I'm a mom, like 2 other women on this call at least. I don't know if do you have children, but we like to tell stories to help get information across. And one of the things that I like to tell about those scary events like Fukushima and Chernobyl, those are scary. And I think it's okay to say that they're scary. I was in the control room at Diablo Canyon when Fukushima happened. And that was my worst nightmare as an operator, honestly, because I'm like picturing these people just right across the ocean from us, and what's going on in their plant, and they have no idea, and it must be super scary. And it was. But I think we have to take a step back and remember that scary is not the same thing as dangerous. And when we finally got, more information about those events and what was actually going on at the plant, not the rumors, there were a lot of rumors, that was scary. But when we actually found out what was happening, the impact turned out to be pretty small in terms of human health. No one was injured at the plant. People were hurt during a panicked evacuation. So we have to really look at, where is the danger, where is the impact, and kind of look at that evenly across all technologies. So when we talk about like safety, I immediately now, I wasn't always like this. It took me quite a while to get my head around, nuclear being safe. But when we talk about comparing coal and nuclear, now I just think like coal is very, very dangerous, not scary. It's not that scary. Lots of people do it. We're around it all the time, but the actual danger from people breathing in the particulate emissions is really huge. So when we look at the impact, from one technology versus the other, coal is hugely more dangerous and damaging to human health than nuclear, and that's just something that's really hard to communicate to people because nuclear sounds scary.
I guess from our position, sort of sitting in the coal industry, and it's a dirty word, but like nuclear, coal-powered fire station, the technology behind that, the best in the world. Those emissions, proven to be able to be significantly brought down. So, i.e., the science is making what was in past times, yes, probably a danger, much more dangerous resource and form of energy, but it's what makes what makes society turn. And I think coal power, certainly where we are, more broadly in the cities, it's not got a terrible reputation, but we see a lot of advances in coal like we do in nuclear, and I guess I see it as a both sort of situation. So it's coal. I see coal's future going for quite a long time yet, but I think that if we want to plug that interim gap into renewables or whatever may come over the coming decades, what we can achieve to power our society renewables isn't doing it now, so it has to be coal or nuclear. So I'm sort of going around in circles here, but yeah, it's just the technology side. So talking about coal as purely as dangerous, I think it sort of forgets the reality of how that science has progressed.
Well, I think one of the big issues too when you compare nuclear to coal is that coal power generation is much easier to understand than nuclear power generation. It's a much more complicated system than coal-fired plants, and I find that misunderstanding or lack of understanding can create fear, and it's very easy, for people to think it's scary and to think it's dangerous and to not be able to separate activities like Chernobyl and Fukushima from your normal power plant. I hear it here all the time as an operator at Bruce Power. We run CANDU reactors, which are very, very different reactors than what they were running in Chernobyl. But we have people who say all the time that, that accident's going to happen on the shore of Lake Huron, and it can't because it's a completely different reactor design.
What's the lifestyle of these sorts of plants and the legacy issues?
Sorry,
like, what do you mean by lifestyle?
The life cycle? Did you the life cycle and the legacy issues, I think is the question. Yeah,
okay,
so life cycle and legacy issues.
Yeah, so right now, like the Bruce Power reactors were built, I don't even know off the top of my head. I know we're just starting to do refurbishments though on the Bruce reactors. 1 and 2 were refurbished and brought back online in 2012. And then the remaining 6 reactors on site are starting refurbs now. And they're projected when the refurbs are done to run till 2064.
Could I just ask a question on that, on the cost of these small units that we're talking about today compared to renewables? Because the state that I come from and the discourse here is that renewables are far, far more economical to run than coal mines, coal-fired power stations. So I just wonder, politicians are only really convinced by the bottom line, as it were. What are and Randall, you're probably the ideal sort of person to answer this. What are the cost comparisons between producing a megawatt of power via renewables compared to nuclear?
Well, that one I may not be the right one to answer that, but I did want to just circle back to a couple of things. Again, I can't say, I won't say, with 6 or so coal-fired plants that it's a dangerous job, because you're absolutely right. And the particulates and the scrubbers that are on those coal-fired plants met all the federal requirements. But overall, as costs come down for renewables, wind and solar, certainly becomes more difficult for coal to compete. Uranium, I think, is so, and I should say nuclear. I shouldn't say uranium because we have different fuel sources. The plant that they're looking at for Wyoming is actually a natrium plant. They say it will use about 1/3 less of, and it's high. I have to write it down because I always forget what it stands for. High assay low enriched uranium, HALEU. And so it will use a lot less than most current nuclear plants do, and therefore you'll have a lot less waste. But in terms of cost, what we saw change last year in particular, when Texas had those series of cold and snowstorms, in fact, the whole Midwest, suddenly we switched from hearing about, the low cost of just wind and solar, but the importance of being able to have 24-hour power, dispatchable power, backup power, and that's something that coal and nuclear absolutely can provide. And it's been interesting to see how that change, that has been a change in the overall conversation. I was going to share one thing. I know you said this could be light and funny, but and I assume that we'll get to that light and funny stage at some time. But you mentioned about the overall public reaction in Wyoming. There was concern exactly, what does this mean in terms of safety? And I also saw there was a question about what the nuclear plant would replace. And yes, they plan to actually replace a coal-fired plant in one of 4 communities. But you know what the real pushback has been so far? Is the fact that TerraPower is owned by Bill Gates. There you go. So that's something that surprised me. It just was an interesting thing to see. So I think Joe, I think I managed to avoid your question pretty well, and I do have children in that. As a politician, but I see Heather is anxious, I can tell, to answer that question.
Chomping at the bit over here. I have a few things to say about the cost of nuclear. First is that I feel like nuclear does a really good job of paying for people. We hire 1,500 people, full-time employees to work at the plant, plus contractors and local suppliers and you know, so many other knowledge type and people type positions. So I feel like that's part of the cost. I also feel like our industry, speaking of nuclear communications, and partly why I started Mothers for Nuclear, is I feel like our industry has done disservice over the years in terms of how we talk about safety. And we respond with a lot of like, oh yeah, you know, we're safe because we have this equipment and we have this equipment, and then we have backups, and we have redundancy and separation, and then, you know, we have layers upon layers, and you know, people come away with kind of a perception that nuclear is really complicated and hard, and like, why does it have to be like that? And the truth is, we've done it to ourselves by responding with technology solutions instead of with communication and what really can, you know, increase the safety margin. We just kind of like keep stacking stuff on top, which adds to the expense as well. I also think that we don't really know yet with these new designs what cost is going to look like. We've been running our existing nuclear power plants for 60 to 80 years. So we know how to do that. What I like to say in terms of nuclear generation and clean energy is that we want to do 3 things. First is save all of our existing nuclear plants, because it's definitely cheaper than building anything new. Keep running what we already have. Number 2, build more nuclear. We have designs. We should be building more of them. We know how to do that. We know how those plants run. And 3, innovate nuclear and build new designs. And with those new designs, I think it's going to become a learning curve. And we're going to have to figure out how to run those plants and how to design them. And there is going to be, you know, cost involved with that. And as some of you might know, we have one nuclear project right now in the United States, in Georgia, and it's, you know, pretty significantly over cost and schedule. And I think a lot of that is because it's a new design, and a lot of it is also because we haven't really been manufacturing and building large projects like this in a long time. So it's going to take us a while to kind of figure that out again too. I visited China a couple years ago, and they were building an AP1000 unit that I got to tour, and I heard that they had similar issues with, you know, lots of going over cost and schedule and way over budget on the first ones, but they learned from their mistakes and, you know, took notes and did better the next time. And they started manufacturing facilities right in the same locations as some of their nuclear plants, so that they could, you know, build these huge, like, they're bending metal structures to make their containment and reactor vessels and like 12 feet thick steel, you know, like we can't do that in the United States. I don't think we don't do that kind of manufacturing, but they figured out how to do it, and they put it right on site with their reactor site. And we're able to start, you know, like after a couple times, really start kind of cranking them out and making them faster and cheaper. So I hope that we can do that.
So Graham, I think you had a question as well.
Yeah, look, not so much a question. Oh, it is a question. It's an observation. I live in a regional community of 75,000 people in a state of 5 million, and we've provided since 1921 not 90% of the state's electricity. Now, with the move to renewables, we had 4 large power stations. They're now down to 3. And we have got the dates for closure of the remainder. And the state of Victoria is moving to wind and solar And when it comes to the dispatchable issue, they're going to rely largely on batteries and pumped hydro. Now, what I'd like to be convinced, and I'd be very interested in Sheila and Heather's comments on this, how does nuclear in America compete with with wind and solar? And I'll give you an observation. In Victoria, our brown coal power stations are rapidly being priced out of the market by wind and solar during the daytime when the solar is at its best. And they're actually only making money in what I call the shoulder, the morning and evening peaks. Can nuclear rival those kind of developments in a market?
I'll go first. So I can only speak to Ontario specific. I'm not that great with Canada-wide, but our province specifically, Bruce Power, where I work, we supply over 30% of Ontario's power at 30% of the cost of like wind, solar, hydro, all that stuff. So like we're definitely competitively priced. Bruce Power is also a private company, so we're not bound by government pricing and all of those things. And there's a big push right now for wind and solar to replace one of our stations in Toronto. The Pickering plant is actually scheduled to be shut down. I think it's 2024 or 2025, unfortunately. And the plan is to replace it with natural gas. So we're taking a huge step back. Ontario is one of the cleanest grids in the world right now. We're a lot of hydro and over 60% nuclear. And so it's going to be a big step backwards. And there's a lot of discussion from certain groups that are against nuclear power that we can pump in excess hydropower from Quebec, which always sounds really good in theory, but they always leave out the fact that we actually export nuclear power to Quebec in the winter when, you know, their water freezes and they don't have enough hydro. So it always looks good in theory, but when you actually dig into it, it's not a possibility. So our nuclear plants here in Ontario are definitely our heavy lifters.
Sheila, can I also just tease something out there? I recall reading in a book by Meredith Angwin, and I think our mutual friend Chris Kiefer also had an analyst on his show that discussed it. I understand in Ontario they took a decision back in, I think, 2012, 2013, that their nuclear power stations would not be curtailed by wind. And I think they might have done this using a minimum, like a floor price. So that, I think that is unique. I don't think there's many other systems in the world where there is a floor price that enables basically, you know, instead of giving the cheapest source at any instant in time right of way on the grid, they say, well, across the 24 hours or across the week or across the month, we're not allowing those kind of intermittent energies to curtail nuclear. They have to work around it. Can you speak to that? Is that the correct understanding?
I'm definitely the wrong person to speak to that. I wouldn't want to misspeak. I know a lot of people who are really good at that particular topic. I'm not one of them. So I would hate to say something that's not correct.
Yeah, I like to also just admit, as Meredith Angwin's book, it's called Shorting the Grid. It's really good. But electricity markets are really complicated. And I actually love to use Ontario as an example of a less complicated one. I went to visit Bruce Station also 2 years ago and learned about their electricity pricing. And it's actually very straightforward because they don't have a lot of these market structures like we have in California that kind of make certain generation sources look to be different prices than what they really are. Like in California, we have a practice called net metering, where solar customers during the day can put their electricity onto the grid and get, you know, the same price for their electricity that they actually, you know, like use that same electricity back at night when you know, actual electricity is much more expensive. During the day, it's cheap because we have a lot of solar. So there's a lot of things, our carbon trading system, and a lot of things that kind of go into what looks like the cost of renewables. But if you look at a chart of actual electricity prices in Ontario, nuclear and hydro are really like right at the bottom. 3 to 4 cents per kilowatt hour, I believe, and everything goes up from there, and solar PV is kind of at the top. So I like to make that comparison. In California, it doesn't appear that way. It looks like nuclear is really expensive because there's all these kind of like hidden processes in California policy that make it advantageous for renewables. You mentioned wind generation. Something that's happening in the Midwest of the United States right now is a wind production tax credit. So wind generators are paid to put electricity on the grid, whether we need the electricity or not. So that forces all other people making power to, ramp their units offline. Nuclear is not really good at doing that, or kind of like a stable base load, our current designs. And so nuclear gets punished in the open market because of these tax production credits for other technologies.
One thing that we sort of like to point out in Australia is, and we have really highly developed renewable solar and wind sector, is wind and solar are very cheap. I would say the short run marginal cost is close to zero, except when the sun isn't shining and the wind isn't blowing, and then they're infinitely. Then the cost is infinite, which is to say you can't get solar and wind energy at any price, and of course we see that. We see high volatility in the spot market price. We have negative pricing during the day. Hard to understand how anyone makes money and pays back their investment in that, or can justify further investment in a market like that. But then we also see enormous peaks in price, and I think that's similar to California, where it can sometimes go over $1,000 a megawatt hour, anywhere up to $14,000 a megawatt hour. It doesn't do that all the time, but it happens frequently enough that, unfortunately, the difference between the wholesale cost of generation, which in Australia is not that high, it's actually reasonably low, and what you pay in your electricity bill, the retail cost that small businesses and households see, is quite different. And our retail costs keep going up, even though our wholesale costs on average are fairly cheap. So that's one of the sort of, I guess, the hidden costs of solar and wind. They are very cheap at the, for the power stations or for the companies that are putting that energy on the grid. It's cheap for them. But to the end user, it doesn't necessarily make it that cheap because obviously it's expensive when it's not there. So,
and I think that's circling all the way back to Randall, your comment about the benefit of always on generation. That's really an important factor when we talk about cost. Heather, did you want to make a comment there as well in a similar vein on the always on concept?
I can't think right now what I was going to...
You're going to say about the backup and storage costs that need to be factored in for intermittent sources.
Yeah. With any intermittent source, I think it's important to consider the costs of storage and backup, and also the life cycle, the overall life cycle. I mean, we can talk about how much it costs to make electricity, but, solar panels, how long does a utility scale solar farm last? 20 years, 30 years, and like how much generation do you get out of that compared to a nuclear plant that could last 60 or 80? And so like it's a cost over lifespan also, I think.
Could I just, I don't want to harp on about the cost, but could I just go back to, does size matter in terms of your population? I mean, I live in a state, and so does James, where we have a lot of land and not a lot of people in parts of it. So to make nuclear viable, do you have to have a substantial and densely populated area? Because my understanding was traditionally that was one of the big negatives for a place like this in terms of nuclear energy.
Yeah, I think, I can quickly speak to that, and then people who know more about it can jump in. But I think that's true in our state, Joe. 2.5 million people, very distributed population in a huge area. Traditionally, nuclear has not made sense for Western Australia. And I would still say that we have to make the case for it in WA. I think the eastern states is a much easier case to make, bigger population. And the traditional units, which are 1,000 megawatts or greater, just simply couldn't be accommodated on our grid. Their electrical footprint on the grid is too big for you and to enable that, to achieve that N+1 network criteria that we need. So it wasn't an option. The smaller units, when you're getting down below 300 megawatts for a grid the size of Western Australia, then you can start to achieve your N+1 network criteria. And so I would say nuclear has become more interesting in Australia because of the reduction in unit size. If you're looking at those enormous plants they're building in the UK at Hinkley Point C, I would say those units are even too big for the eastern states grid, just in the size of their electrical footprint. So I think your comment's a good one.
James, just a question. Has the Australian Nuclear Association, have you guys looked at, like you're sort of talking about sizes, and then, but yeah, also locations. What would be the perfect geographical scenario and location and size of to say power the east coast of Australia?
Sure, that's a good question. I would say there's a few things you need. You need cooling water. That's a must. Most of the designs coming out now do have hybrid or even dry cooling, but there is an efficiency penalty for that. So you ideally want good cooling water infrastructure. Happily, most of the places where our coal-fired power stations have decent cooling water infrastructure that's already been built and paid for. You need access to the transmission network. There's simply no point finding an ideal location for a nuclear power station that's quite off the beaten track and then having to build a high-cost transmission line there. You want it to integrate with the existing infrastructure. And again, existing coal-fired power stations and their communities have that infrastructure in place already to enable the transport of massive amounts of power to major load centres. So I'm thinking places like the Latrobe, the Upper Hunter, have that in place. Another thing, I guess one advantage of nuclear energy is you're not as limited to where you put it because of the density of the fuel source. With coal-fired power stations, traditionally you want those near your coal mines. You want to reduce the cost and the time and the effort needed to transport the fuel to the power station. Because you replace 1/3 of the fuel in a nuclear reactor every 2 years or 18 months to 2 years, and because that can come in on the back of a truck, you have more siting flexibility, I would say, particularly with the newer plants that have got smaller emergency preparedness zones and that sort of thing. So nuclear is quite flexible. To make it really economically stack up, I think we'd want to have a hard look at existing coal communities, but they're not our only options. And ultimately, the biggest thing for nuclear is it's not going to get built unless you've got a community that really supports it and wants to see the investment. So I'd say that's the single biggest challenge in Australia. Graham, I think I saw you put your hand up as well.
Yeah, look, just moving away from the practicalities, cost ratios, etc. of nuclear, along to community acceptance. It's great that Randall's on this call. Randall, you come from a traditional coal communities and you're moving to nuclear. How did that play out in the public opinion arena? How did your, obviously it's going to happen, or appears to be going to happen, how did your community move to acceptance? What actually prompted that?
Well, Graham, I think that's a great question, and it was interesting. I think all 4 communities, when it was announced that they were being considered, it's my understanding that all 4 communities made presentations to Terra Power and Rocky Mountain Power of why they were the best choice. And I think the reason is pretty stark. It's you're faced with losing the coal mine and the coal-fired plant, or you're faced with just losing the coal mine. And I think that's where people started to see that, a lot of this is maybe inevitable. So you want to have the best shot you have of keeping as many jobs as you can. But again, it's just been very, very interesting. And I predicted that once Once the site is selected, I suspect there will be more opposition. But the other thing we have that I will say TerraPower has done a pretty good job at is that differentiating this unit from, say, other generation 4 reactors. Small modular, small being the key word, not taking up a lot of room, 350 megawatts, and it can shoot up to 500 megawatts. All that seems to play pretty well. You mentioned, an area with very few people. That's Wyoming. Wyoming has fewer people than any other state, actually by about a long shot. So it's been interesting to see that change. And before we leave, James, and I appreciate that, you didn't really want to talk technology, but I'm trying to hijack your whole thing here. But I was curious. TerraPower is talking a lot about this natrium technology, the use of sodium, for cooling, molten sodium for cooling, as well as heat storage. I think that I would really like to hear what Sheila and Heather know about this, and I'd be curious of their views as well. So once again, I've showed you my old political leanings to not answer the question and attempt to hijack everyone off in a different direction. So.
Sorry, Randall, I didn't hear. What did you want our opinions on?
The natrium technology and the use of sodium as a coolant and molten sodium, to store heat. So.
Yeah, I don't have any strong opinions on that. I was going to talk about the community acceptance piece, but I'll let Heather answer that.
Well, we're still on community acceptance, so we can wait on that.
I just didn't want to hijack your question.
I don't know that much about advanced technologies either. And like I said, I think we need all of the above and more of all of it as soon as possible. And I do think it'll be great once we develop those technologies that are smaller and more flexible, that we can put them in areas like Joe mentioned that have smaller populations. I did also see a Facebook question about the number of nuclear plants to power Australia. I looked up the population. It looks like it's about 25 million. And our plant, Diablo Canyon, provides power for about 3 million people. So we would need, 8 or 9 Diablo Canyons to power all of Australia. But if we start, mixing in some small modular reactors, some different technologies and stuff, we can provide clean energy for everyone in Australia without having to send it giant distances. And I'm super excited for that future.
Tell me, how are the existing energy providers and energy retailers looking at this, and do they have any appetite here in Australia?
It's a good question. We have not spoken.
The way I see it, they could be a pivotal part of the education and acceptance of the idea of nuclear.
Yeah, I think that's a really good point, and there's interesting discussion to be had about some of the retailers who are selling electricity that is quote unquote zero carbon, and there's a growing demand for particularly businesses who only want to buy zero carbon electricity. I think we need to remind people that is an accounting fact. That doesn't happen in the real world. So when you pay the zero emissions electricity from your retailer, they're not saying that every electron we send you has been produced by solar and wind. What they're saying is we're going to do some accounting and buy enough at different times so we can say on paper that it's zero emissions. One thing I think would be really interesting is to speak with retailers and say, why don't you go to the next step? Why don't you guarantee that every electron you're sending is in fact zero emissions, not just an accounting fiction? And that's where I think nuclear power and coal with carbon capture and sequestration would also have a role to play here, I think. But that's where you can start to really make that a genuine, sales pitch and commitment, not just a little bit of sort of pithy greenwashing, let's say. Just circling back to but to answer your question, Shane, the answer is other than a few emails we get from people within retailing groups sort of wanting a bit more information, there's not a big, I would say, interest at the corporate board level. It's more sort of individuals within those companies that reach out to us and ask for information from time to time. With regards to Natrium technology, really quickly, Randall, we've had some discussions with TerraPower. They've been generous with telling us about that. There's a few advantages that we can see. One is the ability to have this quite significant capacity for thermal storage. So instead of trying to store electrons, which is difficult to do in batteries and it's hard to scale it, you're storing energy as heat, high-grade heat, 500-degree heat. And what that means is you can run your reactor at a set power constantly. You don't have to ramp up and ramp down. So nuclear maneuvering can be tricky, and we've got experts on the show who can tell us about it. But the steam turbine system connected to that heat source can go up and down more readily. And so it means that you have that option to go from 345 megawatts, which is the reactor power output, up to 500. When you've got those peaks in the morning and the afternoon, you can, from an investment perspective, you get to capitalize on that energy arbitrage. But you don't have to maneuver your reactor up and down. I think the other thing is, Graham, it's a very low pressure system. So if you can imagine, instead of having 600 or 900 pound piping systems, you're talking about 150 pound piping system, because it's operating at just over atmospheric pressure. So that also brings the price of the plant down quite significantly. So we think the technology is interesting, but there's a lot of other really good stuff happening. I mean, there's NuScale, there's GE Hitachi, X Energy. It's a really broad space for people developing technology. So it's encouraging.
James, I was keen. Sheila was just about to talk to me about community acceptance, and we've run away from her. Is there any chance I could hear from Sheila around what her community, how comfortable they are with a nuclear plant in their community, and how did they arrive at that level of comfort?
Yeah, so I think we have a unique situation here too in Bruce County where Bruce Power is set up, because at one time of the 8 units we have running, 4 were actually shut down. And the surrounding communities took a huge hit from that. People were losing their homes, house prices plummeted. So I feel like the communities around here have a real appreciation for Bruce Power and the nuclear industry and what it actually means for employees and the communities, because we've seen what happens when it's not there. People had lived it. They know how awful it was. And restarting the Bruce A units was huge. It totally turned the economy around, which was great. And there's a strange thing that happens with nuclear facilities is the closer you get to the facility, the higher the acceptance rate of the facility itself, which is usually because the people surrounding the facility are the best educated about the facility and they know the most about it and they're most exposed to it. And here right now in Bruce County, we have this strange thing happening when, as James said at the beginning, when we're a suggested host for the Deep Geological Repository for nuclear waste, there's this weird dynamic happening now where all of these people are coming out of the woodwork that seem to hate nuclear power, but they never really said anything before. So I think it really comes down to how they feel that something affects them personally. I know we have a lot of people, who are worried about their land value and things like that surrounding the potential DGR. But Bruce Power has proven that, farming can happen right next to a nuclear facility with no problems at all. It's been happening for 60 years safely. So I find it does come down to perception, how you feel it affects you as an individual, and just in general education, educating the public. And Bruce Power does a fantastic job with educating the public. They're out there, they're donating money to the communities to make sure the communities are thriving. They're hosting, town hall events where they have a phone-in event where you can just phone in and ask questions of the CEO or the CNO or whoever's hosting it. So they do a really good job. So I feel like education is the key.
Thanks, Sheila.
Just on politically, where's the big support in our country politically, state and federal level?
Or
is it just too hard?
Yeah, I would say that it does seem to be that the National Party is open to a conversation. I would say, past that, it's not really a party thing. It seems to be that there's individuals within both the Liberal and Labor Party who are open to it, who want to learn more, and there's individuals within both parties who are not as, I would say, not as open to it. When we look at the Australian population, and we can filter by political leaning how they voted at the last election, we see a pretty high level of support for nuclear energy as an option. Okay, so this is not people saying nuclear today, because firstly, that's not a reality. It takes a long time to build, but to consider it as an option in our energy future. I mean, if you think about it, it's taken well over a century to build our current energy infrastructure. To gradually replace it is going to take many decades. But you see consistent support across all the political parties, including the Greens. Some of the polling that we've seen indicates that 55% of people who voted Green at the last election support nuclear power as an option going forward. And our event last week was Greens talking to Greens. So an Australian sort of Greens political member talking to a Greens MP in Finland about how the Greens in Finland have reversed their long and very adamant anti-nuclear position to now they're quite technology neutral, including being open to nuclear. So it does seem to be that political change is afoot. I don't know how long that will take to play out in Australia. I don't have a good sense of that. What is the here's a question for the Australian participants. How is nuclear energy, to the extent that it's even discussed, perceived in your communities?
I think most of the people that I have conversations with have an open mind to it, but I think that may dramatically change though if we go, well, there's one, we're going to replace Liddell, for argument's sake, with a nuclear reactor, with all the cooling, tap straight into the grid, makes sense. The space, the land, all the infrastructure's there. Right, let's put a nuclear power reactor where Liddell is, and take care of baseload power for our part of the world and Sydney and whatnot, and good part of the East Coast. So I think that how they would react, I think would be probably pretty strong. It's that whole not in my backyard thing. I think that's what needs to be addressed, so that people are comfortable with having these things in their backyard.
Yeah, I'd have to say that the fear factor really needs some education. I mean, people here would love to sort of have jobs and know that there's a future for the town and for its people. But before anything like that could happen, you'd obviously have to convince the politicians, but you'd also have to convince the locals that, this is a good thing. And I think that because of the political discourse in this state for a long, long time, nuclear has just been seen as a big bogeyman that sort of nobody embraces really, regardless of their political affiliations. So yeah, I'm really interested in this small nuclear sort of discussion, and we've moved on from Chernobyl, I would have thought, but I think that's what's lacking, and I mean, it doesn't matter whether your job's going or not. If something like a nuclear power plant's going to be in your backyard, you'll always have people who, the fear factor takes over, unfortunately.
In my community, with the impending closure of the brown coal system over the next 10 years or so, the community's total focus is what replaces that in our community. Their total focus is on jobs. There has been no suggestion in nuclear. So nuclear really, how can I put it, isn't on the agenda, isn't on people's lips. People aren't discussing it. Is it an alternative they would consider or not? So as a community, we're very much still at the level of trying to work out what we do. after the closure of brown coal, and would take a fair move ahead. And I think Shane's quite right. There is a knee-jerk reaction in most communities that nuclear is bad, and that's the first hurdle to overcome.
I really
Wonderful.
want to tell you all a story, but I saw Sheila had her hand up a while ago too. Do you still have a comment, Sheila?
Yeah, just a second. We see that happening here too in a very nuclear positive county with Bruce Power here. It's the largest nuclear facility in the world that's operating. And, you know, the NWMO, the company that's running the DGR, they started with 22 communities that came forward volunteering to host this DGR, volunteering to learn more about the process. And no one in our area said boo about it until we got down to the final 2 communities, and then it was a big deal. And I strongly believe that it was that recognition of, oh my goodness, that can actually affect me. I don't want that here. Like, I wasn't against it when we were, you know, taking all the learn more money and things like that. But now that it might actually come here, like, that's a problem. And it is that my backyard and that misunderstanding about nuclear and what it actually entails.
Thank you so much. Listen, we've filled up our hour very easily. I could keep having this conversation for a fair bit longer, but everyone's got places to be. So I just wanted to say thank you very much to all our participants. They've all made themselves available across many time zones. Thank you to the Stand Up for Nuclear team, so Paris, Emmett, and Mark Nelson, who've helped coordinate the activity. Thanks to Tyrone in particular, who's working in the background to bring questions in and to to make the event happen. Thanks to my co-host Helen. And it seems to me that the Australian people who are advocating for nuclear energy in Australia have their work cut out for them. We've got a lot of communication to do. We've got a positive message that we need to get out there, and we've got the the tyranny of proximity, which we need to address in people's minds. But I don't think any of those are insurmountable problems. Thank you very, very much. I appreciate your time. And perhaps we can even think about doing it again next year and get an update from Wyoming about how it's going.
Interesting. Sounds great.
Thanks all.
Thank you.
Bye.
Take care.